Just to put it in perspective, the biochar industry currently and what's developing and what all the good guys are doing gives you the opportunity to put up to 5 tons of biochar into 1 hectare for soil health and agriculture and crop yields and all that type of stuff. In our system, we put 300 tons into 1 kilometer of road, which is the same size as a hectare. So, it's 5 tons versus 300 tons. Reclaiming of waste, as mentioned before. The reason why I put it in here quickly is this whole lighthouse thing and the development internationally is always slowed down because you have to source funding. Where is the funding coming from? And that's always it inhibits or stops projects from getting up and going. Now we are in a situation where the funding is ready for us. They're just saying, we need a business plan. So as soon as you bring a business plan, the funding is there. All these big groups that you see here, and BioFest, they're all ready to jump in with equity, with money. They want to do this. We just need to be able to do it at scale. That's the main thing. So if we can scale it up, if we scale up the construction char, it also makes the agri-char cheaper because your process, your cost of production comes down. And that is the real seed to get things going. Sorry, I'm very passionate. So.
Don't apologise, but bring back the microphone, please.
Oh, you want my wallet again?
No, just the microphone. Thanks, mate. I'll take your wallet later. Did you have a question, Mr. Ivory?
I do, for Andre. So I'm interested in obviously producing biochar and working out all the economics and stuff. So I'd be really interested if you could just let us know sort of what sort of numbers you're talking about in terms of sort of dollars per tonne that you pay for carbon, and whether you go and sort out your own carbon credits. So in other words, are you selling the carbon credits, or are you expecting the char to have had the carbon credits sold on it already?
And I was thinking we were going to get a question from Jim's mowing franchise about what he could do with his leaves. That's a pretty in-depth question. Andre, how quickly can you answer that one?
Fairly quick, because I've had this one a few times already. First of all, around carbon credits, we have a sideline sister company running where we're developing a carbon trading platform. And again, that was born because there's so many small players and remote and rural guys and guys that know what they do if they plant tomatoes, but they have no idea, they don't understand the carbon credit scenario. So we normally walk in and we says, if we get a pyrolysis unit going, multi-purpose, clean stuff and dirty stuff if it's needed, and we'll do all the work and we'll fund the whole road to certification, because every plant needs a life cycle analysis, and you get, there's many engineers, South African engineers don't charge that much money, but the Australian engineers are expensive. We fund that carbon trading platform side of it as well, and then we say, okay, we'll keep 30% or 50% of the credits, and we'll give 30 or 50 back, especially if it's a mining client. They're desperate for offset credits. So we can do a credit bartering. Now credits can go through the regulatory process. Australia now, I think and she'll know, I think it's about $25 to $35 a credit. The voluntary process, as I say, that yo-yos anything from $120 up to 500 and something euro. It's like a Bitcoin. It just jumps up and down. So that side of it, the value derived from carbon credits can be big. From cost of biochar point of view, it depends if we have to pay for the feedstock. It depends if we get the feedstock for free, but we have to mulch it or chip it or whatever. Depends on if some of the feedstocks we get paid to take them. I've done not simulations. We actually received a $2.7 million grant from the government to process all the fire-damaged forest woods on Kangaroo Island, to start that process off. Cost of production for construction char, can be as low as $120 a ton, per ton, not per cube. When we incorporate it into coal premix situations, we can afford to pay up to $350 a ton and still be cheaper per square meter installed compared to hot asphalt. Obviously, your agri-charge is much higher priced, up to 700 or whatever, 800. But the future predictions internationally is that, in general, biochar price will come down to below 200. It has to feed or to get volume going at scale. So our next project, which I've not mentioned yet, that we started now, and that's actually our main line that we're pursuing, is we are now producing, or we have the ability to produce, a construction char that can be used not only for coal premix, for hot premix, for concrete additions. So, and it's all about the bonding mechanisms, and to make it inert and to get it in at volume or at scale. The good guys in Singapore and Norway, they're the leaders in the market in this field. They can get 1 or 1.5%, or in some cases up to 3% biochar into construction material. We can do 25. So
your question around feedstocks. This is for biochar as well as the biodigest and everything else. What is the actual waste stream that you're targeting here? It seems to have a sustainable long-term business. You're going to need a sustainable long-term supply. Then the question around that goes to cost. If you're using a waste stream that is low cost or free, common sense would probably suggest that once you start making money out of it, then you're going to have to pay for the cost of the feedstock because it will no longer be a waste stream. So what is the vision there? Is it local government FOGO bins? Is it the suburban waste? We don't have industries such as timber and that sort of thing, similar to Europe and North America, where they have a lot of biological waste coming out of that. Quite happy with the technology and the demand for the product. That doesn't seem to be a problem, but our systems here are very different to what exists in other parts of the world. So yeah, interesting to see what you're targeting there.
yeah, thanks. Interesting. Appreciate the concerns, because it's valid concerns. Our ability now, one of the biggest available waste streams is our sewage industry. There's massive, there's tens of thousands of tons of sewage sludges stockpiled everywhere. That's a sustainable source. We can utilize it, even though most sewage systems is contaminated with heavy metals and all kinds of other stuff in there. Another big source is the cattle industry, the cattle poo. So I know the clever guys make fertilizer, etc. out of it, but we can pyrolyze that into a biochar that can be added to some more poo as a fertilizer.
What about paper? Waste paper?
Yes, so waste FOGO, the whole range of FOGO. There's, I mean, the availability of that is everywhere where you've got a city, you've got lots of that. What's FOGO? Food, organics, and garden waste, or something like that. There's massive amounts of sawmill fines that's lying around. Now we can incorporate sawmill fines not only as a feedstock for pyrolysis, but we can actually use it as an aggregate because our emulsions makes it inert. Other massive streams, we can put a system right up on your existing dump yards, and start working that away. Tires, plastics, we can use it all. So the commercial sustainability of it is, we will struggle for the next 20 years to actually commission enough pyrolysis units to be able to utilize all the waste. Then Thailand, we're already on a big mission to actually use energy crops, because now we have the ability to side by side back up these guys, Pyrec and all these guys that put up biogas or bio-friendly processing plants, pyrolysis-based energy plants, because there's a lower yield biochar coming out from those systems, but it's concentrated and heavily contaminated. Well, what do people do with that? The latest one that we're doing, we've actually incorporated a company now specifically for that called Collie Envirochar, and we're putting a fairly decent pyrolysis plant up in Collie to co-pyrolyze coal fines with organic wastes, any biosolid or biomass waste. So how many millions and trillions of tons of unwanted coal fines are lying on top of the world? Everywhere you have a coal region, busy oxidizing and busy turning CO2 back up into the air. So we can co-pyrolyze coal fines together with contaminated waste. Now, the availability of that feed, my great-great-grandchildren will still see coal mountains everywhere. So it's a bit of a touchy subject because sustainability, but previously mined material that's lying there that's now a problem. If we process that, that should be able to attract carbon credits. And I've been fighting for the last 2 years with Carbon Future, South Pole, Puro Earth, all the big carbon trading platforms. The moment you mention coal, they say, we don't want to know. Now we have support letters. They say, okay, yes, it makes sense. If you co-pyrolyze coal, all your lignite and all the bad grades that's just lying on top of the surface, on top of the earth, if you co-pyrolyze with a bit of biomass in there, it does attract carbon credits. We've also been approached by the mining industry, not only in Australia, but worldwide, Africa as well. If you have a remote and rural mine site, they have a camp. They produce a lot of waste. A little pyrolysis unit processing all the waste and all the vegetation or organic-based stuff, producing a biochar that they then can use to mix with emulsion in their own local soils and build their roads and infrastructures and that whole lot. So that is a commercial viable opportunity that definitely is going to get there, because on top of that they also get their carbon credits that they're so desperate for. But contaminated mine dumps, we use low-grade copper slag as an aggregate together with natural fibers that come from the hemp industry now, because the hemp industry is growing massively. In Thailand, there's dedicated energy crops, and we utilize natural fibers of that for construction product, as well as pyrolyzed versions. So the sky's the limit here. We just need the funding, and we got it. Now we need the partners to support us and have a bit of passion, and let's make it work. Let's get up early and burn something. Sorry. So your normal hot mix asphalt plants is a long tube. And stuff gets mixed in that tube, and it gets heated up because bitumen doesn't stick to something that's cold, it doesn't stick to something that's wet, and it doesn't stick to something that's dusty. So aggregates gets washed and cleaned and dried and heated, and then you add hot asphalt, hot bitumen to it, and you have hot asphalt. All the plants nowadays have a polymer section as well, P&Bs, and they, specialized hot mixes. The final process, as it comes out, the big kiln, the big pipe, it goes through a little puck mill. So a twin shaft puck mill, that's the only thing we need. We don't need the pipe. We need the puck mill. We feed in a combination of quarry dust as a filler and aggregates, up to maximum 10 millimeter size aggregates, and X amount of biochar. We dry mix for about 20 seconds. We add 10% emulsion. We wet mix for about 10, 15, 20 seconds. Drop it out, ready to use. So we can utilize hot asphalt plants, but we only need a small portion of it.